So the NeoPulse framework, what we did was we created something to automate machine learning. And so what that means is that using AI Studio, we actually have an AI to build AI. So this AI knows something like between 700 to 900,000 different algorithms. It knows how to do hyperparameter optimization. It can solve audio, video, text, like images, regression problems, you name it. It can basically do that. We can also do audio, so we can also do image regression problems, and it's a very, very, very big list of things we can solve. And also very soon we can do GANs as well. And we're actually already using it with the University of Washington. So the NeoPulse AI Studio, it's an AI to build AI. It's an AI to build AI. We call the AI to build AI the Oracle, obviously with matrix reference there. We can't have like a capital O for obvious trademark reasons. So we just call it the Oracle. And so what it is it's a server application, so which means that it exposes a set of REST APIs that you can actually call remotely, and you can integrate that into workflow, so you don't need to physically be on the machine to do anything. You can include that as part of an execution framework. A good example of that is what we're doing for Stanford right now. Stanford University, they're using NeoPulse. They actually have an on-premise version of NeoPulse, and what they want to do is actually fully automate the process. So in their case, what they're doing is they're ingesting DICOM data. So DICOM are basically 3D images that are, for example, that doctors use for PET CT and things like that. So literally, for training a model, all they want to say, these are the 10 different classifications that they're going to just put it in different folders. AI Studio just ingests that, trains a model, outputs a model, displays the metrics. So literally, the doctor just presses start, and that's it. Nothing. It doesn't need to do anything else. So that's kind of, so the goal of AI Studio is to put AI into the hands of everybody. So for people who really know what they're doing, AI Studio offers them the ability to firstly try out things quickly. So I use AI Studio all the time in fully automatic mode using the Oracle. And sometimes I use that as sort of inspiration for kind of what I want to do next. Other times, if it's good enough, I just use whatever the Oracle generates. It's usually sufficient. And usually the Oracle outstrips humans. So in fact, for certain types of problems, the Oracle is better than people. So you'd have a hard time to get a human to do better. So the output of AI Studio is something called a PIM, or a Portable Inference Model. So PIM basically, the way to think about that is a platform-neutral object. It's a container that contains a neural network, or a set of algorithms. It doesn't necessarily need to be a neural network, and a standardized way to access the contained model. So which means that it provides a way for the runtime, which is the next thing, the runtime to access the model, interrogate it, and also optimize access to it. So think about it this way. So when you want to build an AI from scratch, suppose you were to use TensorFlow or anything else, you're going to have to build an entire infrastructure around that too. You're going to have to figure out a way to integrate your AI with the TensorFlow model. You're going to have to figure out a way to marshal the data in a certain way so that your model can consume it. There are a whole bunch of steps that you need to take in order for your model to be used in production. So what the PIM and the runtime do is they automate all of that for you. So literally all you need to do is just import the PIM into the runtime, and the runtime will automatically marshal the data for you. It'll generate an interface for you. It will optimize on the hardware that it's sitting on. So for example, if it's a low power ARM64 device, and we'll be able to kind of work with that. If it's on and very soon we're also going to be looking at FPGAs as well. So it can, in theory, down the line sit on a pacemaker, so if you want. So that's kind of the level to which we want to reduce the size of the models and make it more efficient. So the query runtime is also a server application. It is a thin client that an application integrates with, and you can actually call it. And what you do is import the PIM into the query runtime, and the query runtime will automatically generate an interface, do all the necessary optimizations, and so your application just needs to call the query runtime. So you just need to know the address of the query runtime, and you're good to go. We've also created our own language. It's a DSL called the NeoPulse modeling language. So the NeoPulse modeling language is a Turing-complete language that can you can do very complex things. You can define your own functions, define your own layer models. You can explicitly describe an architecture. You can specify hyperparameters, all of that, if you know what you're doing. And if you don't, know what you're doing, or if you're somebody who is just starting out, or maybe even you know what you're doing, but you want to get, you don't want to necessarily figure out all the hyperparameters in your problem, you can get AI Studio to do that, and you can use it in some level of auto, so automatically generate the hyperparameters and figure out the right architecture and so on. So NML gives you all of that. So the overall flow is you have your data as a .csv file. So the .csv, so we've chosen a .csv file for a number of reasons. One is that typically you want your ground truth to not change while you're training. It may change over time, but then that's a different model, or it's an update of the model. But while you're training, the ground truth should more or less stay the same. Otherwise, you're not going to be able to build a consistent model. So we ingest a CSV file. It's the most easy way to ingest. It's also extremely efficient because it's a flat file. And that also means that you can develop so NeoPulse has some very efficient ways to ingest that information. So it's leveraging a lot of the techniques that are used in deep learning, that are used in big data in terms of how you ingest it, and some of the I/O types of operations that kind of make it efficient. The NML file, so you ingest in AI Studio, you submit that, you compile it, so it's a compilable language. AI Studio will generate a model, and then you can export a .pim object. The .pim object can go anywhere as long as there's a runtime there. So we currently have runtimes that are sitting on, so with version 3 we'll have, which is coming out soon, we'll have ARM64 supported out of the box. We already, today, we support AI Studio on Azure. So the runtime is sitting on Azure, it's sitting on AWS, obviously on premise. We're also on SageMaker too, so we can use the entire end-to-end framework on SageMaker, so leverage the power of NeoPulse while sitting in SageMaker. Yeah, so basically once you output that, and you just import that into runtime, the runtime will automatically generate an interface. It's currently a REST interface that your application can call very easily. And so, which means that you don't have to explicitly define an interface. You don't have to explicitly define any sort of data structures that are needed to query the model, and so on. So the other thing that, which in version 3, what we're going to do is, so another thing that will happen is, and I'm sort of giving you a heads up on a lot of this stuff, is we're also going to be including the ability to associate metadata with your .pim object. So this includes a lot of the manageability factors that you'd normally be concerned about would be inside the .pim object. It includes things like data provenance, what data was used to train it, did the data change while, so for example, to prevent fraud or something like that. So exactly the kind of problems I was talking about. traceability, which means, for example, you can query the runtimes in production and determine what versions are running in which environments. So you can figure out all of that. You, like, obviously author information. You can also have information about what the PIM actually does. You can associate all kinds of other metadata with the .pim object. So it's fairly self-encapsulated. It goes anywhere. It's also sort of unique in the industry because it doesn't have it. It's a very nice kind of formalized way to ship a .pim object to run. I mean, the other thing is that it also offers commercialization opportunities. If you, for example, train a PIM and you're confident about it, you can offer it for sale, or you can offer it. You can generate your own interface in the cloud and allow people to access your PIM. So it offers a completely different business model for people. So instead of being so rather than if you have really compelling training data, you can build a model around that, and then you can then expose that in either in the cloud or offer PIM that people can use, which you license for quite a bit of money or something like that. So depending upon what you're doing. So it definitely opens up business opportunities. So the PIM can go anywhere the runtime is sitting. So the runtime, as I said, you can put it in a number of cloud environments. You can put it on premise very soon on ARM64 devices. And also we're currently working with one major IoT chip company to put it on FPGAs as well. So which means these are ultra low power devices that, for example, only have about 2 megs of memory. And so being able to query a model with such a limited size is challenging. And FPGAs have all kinds of other restrictions associated with them. The nice thing is that you don't need to do anything. You just, all that it gets included in the PIM, and the deployment is fairly straightforward. So in terms of what it can do image classification, automated tagging, and also bounding boxes, so that's already supported as well. So these are things like, this is actually called an image regression types of problems, where you associate shapes with coordinates on a page. So we have an example of that where, so if you go to GitHub, we have an example of that, of a bunch of traffic cam type of pictures where you can identify the person's face. So because the training data includes a bounding box around the people's face, and so you can actually train a model so that when it detects a face, it will kind of put a square around the different faces. We do audio recognition, so audio recognition can be used in many different settings. Think about it as really frequency analysis. So when you think about audio, basically you're analyzing a sequence of frequencies over a period of time. So which means that anything that has that, you can basically use audio recognition for that. An example could be you're on a plane, you're trying to detect vibrations in the wing, and looking at changes in that. It's a frequency problem, so in which case you can use AI Studio's audio recognition to determine fluctuations there. Text analysis, we do basically analysis of documents, individual sentences. So sentiment is a classical example, and that's one of the demos that we can give you today. And so what the sentiment analysis problem will do is it will tell you like whether it's positive or negative, or you can have multiple text classifications. You can also use this for auto generation, like generating headlines, which is what I was talking about. Video analysis, so there are 2 ways to analyze videos. One is frame by frame. Another one is sequence of frames, so which means that frame by frame will tell you that there's a dog or a cat in the picture or in the movie, but analyzing a sequence of frames will actually tell you what the dog or cat is doing. So it's kind of motion analysis. So we have another example in our GitHub repository where we have somebody jogging, somebody boxing, and so on. And AI Studio can determine what the person's actually doing, so you can train a model to do that. The other thing, we can also do regression types of models. So this would be, we use this extensively, for example, financial analysis. So you take historical data, try and make predictions about the future. It's multivariate regression, so it operates in multiple dimensions. We also do other types of time series analysis that, for example, can predict increases or decreases in certain values over a period of time. So there are many things that we can actually accomplish there.